Hello, welcome back to my recorded classes. So, this recorded class we are discussing the topic or some examples from the topic section number 2.3 recursive definitions. It's from module 2 induction and recursion. So, let's start the content here. Section number 2.3 recursive definitions. So first, what is it mean by recursion? Recursion is the repeated use of a procedure or action. Repeated use of a procedure or action, or we can say the procedure call itself at the some point of that one, at the some point of the code. The procedure will call itself. See, for example, here one Python code is given for writing the first n odd numbers, odd recursion of n. That means first n odd numbers we need to write. You know what are the odd numbers, correct? 1, 3, 5, 7, like this going, correct? So odd recursion n means this code meaning the odd number, first n odd numbers. For example, if n equal to 1, that means the first odd number. What it will print? Print it is 1 because 1 is the first odd number, correct? Now else what we is printing 2n minus 1, 2n minus 1. After that the odd recursion n minus 1. That means we are using the same code here, whatever here the smaller version. Odd recursion of n, odd recursion of n minus 1. This process will repeat that one. Now for example, if it is asking odd recursion 5 means first 5 odd numbers. So this code will run, you will get first 5 odd numbers 1, 3, 5, 7 and 9, correct? So here one recursive call is there, repeated call. The process is repeating, correct? And here one base call is there. Base call means the starting initial step, okay, or input step. That is the base call. If n equal to 1, first odd number it will print 1. Otherwise, this process will repeatedly use the same code, odd recursion n with the small version, correct, with its small version, or the procedure call itself. That is the meaning here it is calling recursion. See, procedure calls itself at some point. See here the procedure is calling itself, odd recursion n minus 1. So this is the recursive meaning of recursion. Okay, now see, a recursive definition having two parts. What are the two parts? As I told, one base call is there, base part is there. Base part means nothing but an initial simple definition which cannot be expressed in terms of a smaller version of itself. That means the first stage here, as I told you, the base call, correct? It is the initial stage of that recursive definition. Now after that recursive step, recursion, that means the part of the definition which can be expressed in terms of smaller version of itself. For example, here see, we are started with odd recursion n. After that, in between the call, it is calling its smaller version, odd recursion n minus 1, correct? So that is the recursive call. So a recursive definition having these two steps or these two parts, one is the base call and the second one is recursive call. Now, what is the meaning recursively defined function? Same like whatever I told here. A function is said to be recursively defined function. It refers to itself such that there are certain arguments calling the base values. As I told you, we have one base value for which the function does not refer itself. Or second one, each time the function refer to itself, the argument of the function must be closer to the base value, correct? Whatever we discussed just before, the same idea here. Okay, let me go to some questions directly. Find f of 1, f of 2, f of 3 and f of 4. If f of n is defined recursively by f of 0 equal to 1, this is the base call, it is given f of 0 equal to 1, f of n plus 1 equal to f of n plus 2. See, this is the recursive call, f of n plus 1 equal to f of n plus 2. So what we need to calculate here, find f of 1, f of 2, f of 3 and f of 4 one by one. We can do this question. Okay, so let's start with the base call. You know what is the base call here? F of 0 equals 1. This is the base call. given in the question. Now f of n plus 1, we have the recursive call. From that we need to calculate what is f of 1, f of 2, f of 3 and f of 4. So f of n plus 1 equals f of n plus 2, correct? This is the recursive call. Now in this recursive call, first put n equal to 0 here. See, n equal to 0. So when n equal to 0, what happened here? F of n plus 1, n is 0. So 0 plus 1 equals f of n means 0 plus 2. Correct? What is mean f of 0 plus 1? F of 1. 0 plus 1 is 1. So f of 1 equals, what is f of 0 is given in the question, it is 1 plus 2. Hope you understood. Because f of 0, this value, f of 0 value is given here, it is 1. So 1 plus 2. So what about the number equal to 3? So f of 1 value we got. What is f of 1? Equal to 3. So from the recursive step we got the first value f of 1 equal to 3. Now from the same step I want to go, what is f of 2, what is f of 3, what is f of 4. So we can do here. Now just substitute n equal to 1 here. First we applied n equal to 0, we got f of 1. Now we are going to do n equal to 1. So f of n plus 1, n plus 1 becomes, n means 1. 1 plus 1 equal to f of n, that means f of 1 because n is 1 plus 2, correct? So what we are getting, f of 1 plus 1 means 2, f of 2 equals, what is the value of f of 1 here? 3, correct? Already we calculated. So 3 plus 2, that means what is f of 2? 5. So we got the next value, f of 2 equals 5 now. So first we applied n equal to 0, we got f of 1. Then we applied n equal to 2, n equal to 1, we got f of 2. Now we are going to calculate, just substitute n equal to 2 there, correct? N equal to 2. So what we are getting, n equal to 2, f of n plus 1. N plus 1 means 2 plus 1 equals f of n, n means 2 plus 2, correct? So what will be the number? F of 2 plus 1 means 3. F of 3 equals, f of 2 just before we calculated 5, 5 plus 2, 5 plus 2 means equal to 7. So f of 3 equals 7 we are getting, yes. So we got f of 3 also, f of 3 equals 7 here. Hope you understood. Now one more value we need to calculate. What is that? F of 4, correct? We need to calculate up to f of 4. F of 4 means next n number apply. N0 we substituted, N1 we substituted, N2 substituted. Now n we equal to 3. We are going to do n equal to 3. So f of n plus 1, that means 3 plus 1 equals f of n, that means f of 3 plus 2, correct? So what will be the value? F of 3 plus 1 means 4. F of 4 equals f of 3. What is f of 3 actually? Just before we got 7, correct? Here it is there. So 7 plus 2. 7 plus 2 means equal to 9. So what is f of 4? F of 4 equal to 9 here. So from that recursive step we are getting what is f of 1, f of 2, f of 3 and f of 4. We have already the base call here. Base call is f of 0 equal to 1. So first we are applying the base call to the recursive step. We will get the next terms f of 1, f of 2, f of 3 and f of 4 here. Hope you understood this question, correct? Yeah. Now we will go to the next idea. Give a recursive definition of the sequence an equal to 1, 2, 3, etc. If an equal to 6n, we need to write the recursive definition. Okay, this is the important idea here. write the recursive definition of the sequence n equal to 1, 2, 3, etc., where an equal to 6n. Okay, so we will do this question in two way. I am doing here in two way. First I am doing in method 1. Okay, after that I will do method 2. Okay, so method 1, just start with the sequence with n equal to 1. See, first initial number is n equal to 1 here. So we can calculate the value n equal to 1, apply. So a1 equals, because an, see an, put n equal to 1. So a1 equals 6 multiply n means 1, correct? So what the number getting? Equal to 6. So first number a1 equal to 6. Now just apply n equal to 2. So you will get a2. An means a2 equals 6 multiply n number is 2. 6 multiply 2 means it is 12. Correct? Now after that just apply n equal to 3. N equal to 3 means a3 equals 6 multiply 3. That means 6 multiply 3 means we have 18. Correct? 18. Like this is continuing. So we can generalize from here. See, for example, in this one, a1 means we are getting 6. Correct? A1 number is 6. Now a2 number we are getting 12. A2 number we are getting how much? 12. Just compare with the before number. Before number is what? 6. 6 and 12 comparing means what we can write that one? We can write 12 means a1 number plus 6. Correct? That is the a2 number. But because what is the a1 number? 6. So 6 plus 6, that is 12. Correct? A1 number plus 6, that is the a2 number. Now when we are going to a3 number, correct? Compare with just before number, a3 number. A3 number from a2, how we are getting from a2 a3 number? A2 number plus 6, correct? Because a2 number is 12. 12 plus 6 means it is equal to 18, correct? Now from here you can generalize. What is the general term here, or an plus 1th term? An plus 1 equals, how we can write this one? See, for example, a1, this is the base call, a1 equal to 6. Okay, that is the base call we can write. A2, for example, a2 means a1 plus 6. A2 second term means a1 plus 6, just before term, correct? 2 means 1 here, a1 plus 6. A3 means how we are writing? A2 plus 6. A3 means before term plus 6. So an plus 1 means how to write? An plus 1 before term means an plus 6, correct? An plus 6 we can write. Hope you understood that one, correct? So how to write the recursive definition now? We can write the recursive definition. I am writing here recursive definition. How to write? Recursive definition having two parts. First write the base call. What is the base call here? A1 equal 6. This is the base number, starting number, correct? Base call. So a1 equal to 6. Now write the recursive step. Recursive step means this general step. What is the recursive step here? an plus 1 equals an plus 1 equals an plus 6, correct? For n equal to what? N equal to 1, 2, 3, like that it is going, correct? N equal to 1, 2, 3, like this is continuing. This is the recursive definition of our question. Okay, hope you understood that one. Recursive definition related to our question. That means what is the base call and what is the recursive call. Now the same term you can write in terms of function also, like this. Otherwise we can write like this in terms of like a function. A1 equal to 6. We can write like f of 1 equals 6. Instead of a sequence we are using like a function f of 1 equal to 6. And an plus 1, how to write? F of n plus 1. an plus 1 means f of n plus 1 equals an, that is f of n plus 6. Okay, where n equal to 1 2 3 like that, it is continuing. So this is the first method, method number 1. Okay, this is when we are doing what is the problem is generalizing. Sometime it is not easy, some sequence it is easy, sometime it is not easy. So I will go to the method 2. This is the more easier way to do like this question. Method number 2, better to go this method when we are doing questions. Method number 2, start with the base call n equal to 1. Okay, just apply n equal to the first number. You will get a1 equal to, as I discussed here, a1 equal to, apply here 6 multiply 1 equal to 6, correct? 6 multiply 1, that means 6. A1 equal to, same like before. Okay, this is the base call. Now instead of doing a2 a3 a4 like that, just start with an plus 1. Okay, generalize that one. So here an plus 1 equals an plus 1 equal. So keep in your mind, what is our an in our question? An means 6 multiply n, correct? An equal to 6 times n. Now an plus 1 means what we are doing, just replace this n by n plus 1, correct? So wherever n coming, just replace it by n plus 1, that is the meaning an plus 1. So how to write an plus 1? 6 multiply, instead of n we are writing n plus 1, 6 times n plus 1. Now just expand that bracket, 6 times n multiply here, 6 multiply 1 means plus 6, correct? So an plus 1 equal to 6n plus 6. Now that means an plus 1 equals, you can see 6n means, what is the meaning 6n actually? It is an, correct? An equal to 6n. So instead of 6n, how can I write that one? An, then plus this 6, that is same. An plus 6. That means just introduce the term an. When you are calculating an plus 1, just introduce the term an, that means the smaller version of itself. That is the recursive definition. So 6n means we can write an plus 6 is extra, where n equal to what? 1 2 3 4 like that, correct? Continuing. So this is the step we are calling the recursive step or recursive definition. The same thing we got here. See, a1 equal to 6 and an plus 1 equal to an plus 6 we are getting. So you can do this method 2 more easier when we are going to do the questions. Hope you understood this question. Okay, now let us practice some questions more here. Give a recursive definition of the sequence. Recursive definition, this is what our question. An equal to 2n plus 1. So I am doing this question by method 1 first, after that method 2 I can do here. So method 1, what we need to do? First just apply n equal to 1. What are the number n? N equal to 1 2 3 like that, it is continuing. So just apply n equal to 1 first. N equal to 1. So a1 equals, apply here an is 1. So a1 equals 2 times n number is 1 plus 1. 2 multiply 1 plus 1 means equal to 3, correct? So a1 number we are getting equal to 3. This is the base call, base number. Now just put n equal to 2 here. So a2 equals 2 times n number is 2 plus 1. That means what is the number? 5, correct? So a2 we are getting equal to 5 now. Now go to a3 after that, n equal to 3 here, correct? So a3 equals, how to write? 2 times n number is 3 plus 1. So what will be the number? Equal to 7, correct? Like this continuing. Now we need to write what is the connection, correct? Base call a1 equal to 3. a1 number equal to 3. Now think about a2. This one, a2 equal to 5. So think about that number, how is connected with a1. See here it is 3, correct? So how can we write that one? a1 number plus 2, that is a2, correct? Because a1 number is 3 plus 2, that is 5, second number we are getting. Same a3 we are getting 7 we need to connect with a2. How we are writing? a2 number plus 2, correct? Because a2 number is 5 plus 2 means we are getting 7. Now we can write what is an plus 1. How to write an plus 1 equals? You can think about, see, a2 means a1 plus 2, correct? a2, second number if you want, a2 means before number a1 plus 2. Same a3 number if you want, a2 number plus 2. So an plus 1 means how to write? Just an plus 1 before number is an plus 2 we are getting, correct? So we got an plus 1 here. An plus 1 equal to an plus 2. Now we can write the recursive definition. Recursive definition. As I told you, recursive definition, we have two part. What are the two part? One is the base call, second one is the recursive part. So what is the base here? a1 equals 3, correct? a1 equal to 3. Now what is the recursive step? an plus 1 equals an plus 2, where n number is 1, 2, 3, like that it is continuing. Otherwise, write like a recursive function. Recursive function means a1 equal to 3. How to write? f of 1 equal to 3, and an plus 1 means f of n plus 1 equals f of n plus 2, where n equal to 1, 2, 3, like that it is continuing. So I hope you understood the first method. Now the same question I am doing in the second method. Okay, how it is working? You can see the method number 2. So what is our question? an equals 2n plus 1. Correct? So as I told you, first what we are doing, we need to create a base call. a1 equal to, just now we discussed here, a1 means what we got is 3, correct? 2 multiply 1 plus 1, 2 multiply 1 plus 1, that means 3. a1 equal to 3. So this is the base call. Now I want to go to the recursive step. So we need to calculate what is an plus 1 equals. an plus 1 equal. So what is an in our question? Already we know an means 2n plus 1. Now here instead of n, what you need to apply? N plus 1, replace by n plus 1. So wherever n coming, replace it as n plus 1. So how to write this step? n plus 1 equal 2 time, instead of n we are writing n plus 1, then plus 1, correct? Now expand the bracket here. 2 multiply n, that is 2n, 2 multiply 1, that is 2 plus 1. I hope you understood. Now an plus 1, that is an plus 1 equals, see, now arrange, we need to introduce the an term here, correct? So how to introduce an term? You know an means what is actually 2n plus 1, that is an, correct? So this 2n and here plus 1. Okay, I am writing together 2n plus 1, correct? Then plus 2 remaining plus 2. So how to write the answer? Equals 2n plus 1 means what is the meaning? The same as an, correct? 2n plus 1. So an plus 2 we are getting. an plus 1 equals an plus 2, where n equal to what? 1, 2, 3, like that it is continuing, correct? So this is the recursive definition of that sequence. Hope you understood this question. The same answer, whatever we are getting here in the first method, see, same answer we are getting. an plus 1 equal to an plus 2, correct? The same thing we are getting here. So generally this method 2 will be easy when we are doing questions, because first method sometimes generalizing is not easy. Okay, now this question we can go only method 2. I am doing in method 2. Give a recursive definition of the sequence an, where an equal to 4n square plus 2. 4n square plus 2. So first what we need to do? First we need to do a base call. Base number we need to calculate. So what we need to do for that? Put n equal to 1 here. N is starting 1 here. So put n equal to 1. So what we will get from here? A1 equals an. A1 equals 4 times n square, 1 square plus 2. What is this number? 4 plus 2, that is 6. So A1, this is the base called A1 equal to 6 here. Hope you understood. Now recursive step, an plus 1 we need to calculate. An plus 1 equal to, that means what we need to do? Replace n by n plus 1. Wherever n coming, you need to replace by n plus 1, correct? So how to write that one? 4 times, instead of n we are writing n plus 1 whole square plus 2, because 4n square plus 2, correct? 4 instead of n we are replacing n plus 1 square plus 2. Now equal to, just expand here, 4 times n plus 1 whole square. You know what is a plus b whole square, correct? Same thing you can use. A plus b whole square means a square plus 2ab plus b square. So just apply that here. N plus 1 whole square means n square. A square means n square plus 2ab, that is 2n, plus b square, that is 1. Then lastly plus 2 will be there, correct? Plus 2. Now again expand the bracket here. 4 multiply n square, that is 4n square. 4 multiply 2n, that is 8n. 4 multiply 1, that is 4 plus 2. Hope you understood that step. Now think about an. We need to introduce an here, correct? What is an actually? 4n square plus 2. So here see, we have 4n square here. We have plus 2 here. This together we can write 4n square plus 2, correct? What are the remaining? Plus 8n plus 4. Okay. Now instead of 4n square plus 2, what we can write? The same as an, correct? An equal to 4n square plus 2. So instead of 4n square plus 2, I can write an plus 8n plus 4, that is same, the second one, correct? So where we started? We started with an plus 1. An plus 1 equal to an plus 8n plus 4. This is the recursive step where n number equal, what is the n number? 1, 2, 3, like that it is continuing. So I hope you understood. So this way, this method 2 will be easy for recursive definition. We can do easily. Otherwise, sometimes generalization is not easy if you are going to the method 1. Hope you understood this question. One more question we can do. Question number 2D here. Give a recursive definition of the sequence an equal to 0, 1, 2, 3, like that it is continuing. Write the recursive definition of the sequence. That is the question here, correct? So we will go to do this question. First we are doing the base call. Put n equal to 0 here. Here first number is n equal to 0. So apply here. So what we are getting? A0 equals 2 times 7 power n is 0 minus 1. Correct? So what will be the A0 number getting? 2 multiply 7 power 0 means 1. So 2 minus 1, you will get 1. A0 equal to 1 here. Okay, now let me go to the recursive call. Okay, so what we need to do? We need to do an plus 1 equals, correct? An plus 1 equal to, apply here, just replace n by n plus 1. So 2 multiply 7 power, instead of n we need to replace by n plus 1 minus 1, correct? Now we are going to simplify. Equal to 2 multiply, actually 7 power n plus 1, how to write that one? 7 power n multiply 7 power 1, correct? That is 7 power n plus 1 minus 1. We can split into 2, 7 power n plus 1, 7 power n multiply 7. Hope you understood this one. Now we are going to simplify this step. Equal to, okay, we need to simplify here. Equals, we need to introduce an. Think about this one in your mind when we are replacing 2 7 power minus 1, 2 7 power n minus 1, we need to introduce there, correct? Then only an will come there. So how to write that one? We can write 2 multiply 7 power n. Instead of this 7, okay, how to write 7 actually? We can write like 1 plus 6, correct? 1 plus 6 is 7. Why 1? The next term is 1 here. See, so 1 plus 6 I am writing is minus 1 same. Now expand the bracket, we can simplify. This 7 power n multiply here, 7 power n multiply here. So you will get equals 2 multiply, first 7 power n multiply 1 means 7 power n, plus 7 power n multiply 6 means 6 multiply 7 power n, correct? Minus 1, that is same. Now again from here you can distribute this 2 to the bracket, 2 multiply 7 power n and 2 to here also. So how to write that one? Equals 2 multiply 7 power n plus 2 multiply 6 means 12 multiply 7 power n minus 1. Hope you understood that one. 12 7 power n minus 1. Where we started? We started with an plus 1, correct? Now how to introduce an there? You can see an means 2 7 power n minus 1. So here 2 7 power n is there, here minus 1 is there, correct? So take together that one. How to write that one? 2 7 power n minus 1. I am taking together that one. What is balance? Plus 12 7 power n, correct? Now you can introduce an there. Instead of this one I can write an, because 2 7 power n minus 1 means what is that? An. So an plus 1 equals an plus 12 multiply 7 power n we are getting, where n equal to, what are the n numbers? 0 1 2 3 like that it is continuing. 0 1 2 3 like that it is continuing, correct? So this is the recursive definition of that sequence. Hope you understood that one. How to calculate the how to give a recursive definition of the sequence an. So we need to have a base call like this. After that, one recursive step, an plus 1. What is an plus 1 in terms of an? Okay, an plus 1 equal to, a smaller version should be there, an plus 1 and an plus some term extra will be there, where n equal to 0 1 2 3 like that it is continuing. So I hope you understood how to write the recursive definition and how to calculate the terms also. Thank you for watching. Please subscribe my channel for getting more recorded classes. Thank you very much.